Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 18th. Brought to you by Vunabaka.com, a new surf and ocean-based residential community in Fiji. First up, we'll take a look at significant sea heights for the South Pacific Ocean. There's really nothing going on in the North Pacific. We're out of that season. Focus is towards the south, and rightfully so. There is a small storm southeast of New Zealand, 40-foot seas in play, and that is the focus as of right now. First, we'll take a look at jet stream level winds in the South Pacific. These winds, of course, help fuel storm development and also drive the storm's path. What we're looking for is the southern half of the jet stream. We have a split jet stream configuration right now. The northern half doesn't really do so much to help storm development. The southern half is the one that drives all the action. Right now, rather weak flow pushing under New Zealand, 100, 110 knot winds maybe. A little bit of a trough here. That is enough of a trough to fuel some gale development in this region. But further east, not a whole lot going on. It's a fragmented flow. But at least there's no big ridges pushing south until you get under like under Chile. But here there's enough clearance from the ice. The ice is down right now. It's at its low point about 65 south. As we get into the southern hemi winter, the ice will start creeping north, which means the jet stream will need to be displaced further to the north to enable storms to form. Anyway, let's go put this into motion, see what's going on. Over the next several days, something that almost looks like a trough is trying to get going, but it's basically getting cut off by this ridge pushing over the southeast Pacific into Antarctica. So no go there. Another trough tries to get going here on about Tuesday. Decent winds too, indeed. 130 knot winds. Pushing under New Zealand, and that decent looking trough here. Actually good formation. Could have more wind blowing up into it here, but not a bad configuration at all. So this is a classic kind of southern hemi trough pushing north rather than northern hemisphere troughs that push south. Okay, and here we go. We're into Saturday, a week out almost, with 150 knot winds blowing up into that trough. So the other little tidbit here is a lot of times the jet stream level models will pick up on things that the surface level models don't. The jet stream actually seems to run a little bit more predictive, a day or two ahead, and then the lower level, the models for lower levels in the atmosphere seem to pick up on it later, and then eventually the wave model is the last thing to pick up on it. Anyway, so we got another little trough there, and that's about it. So there is some more potential, it looks like, under New Zealand. Next, we'll take a look at surface level winds, surface level pressure, and sure enough, here is the gale that we were talking about earlier. It's about a 964 millibar low, southeast of New Zealand with 45 knot winds pushing northeast, pretty well up the Great Circle paths to targets up into California, Peru, Costa Rica, down into even Chile to a certain extent. But I think the bulk of this storm has already run its course and it fades out by Monday. Another gale is projected, 960 millibar low, 40 knot winds, pretty much east-west. You really want the winds pushing a little bit more northeast to get up into U.S. coastal waters. So we're into Monday night, and this one kind of fades out, 40 knot winds, not a whole lot going on. Then we get another one, another 45 knot or so system on Thursday. Actually, earlier runs of the model had a far stronger system in this region with 55, 60, even 65 knot winds, and that was even just 24 hours ago. But now that system looks to just sort of peter out and get squashed south, and that's kind of the end of it. And then not a whole lot happens. Another, you get 35, 40 knot winds, but to get a good, strong 17-second period swell, you're going to need 45 knot plus winds blowing for 24 hours really. And so things peter out. So the jet stream looks good, surface does not. Surface level models don't look particularly inspiring. And next, let's take a look at the wave model. So again, as we talked about earlier, 40-foot seas here on the Great Circle paths up into Northern California, but a little bit shadowed here. Actually, we can put this back a little bit. So this system really got going on Saturday night. It was as it was pushing under New Zealand. Here, you can't see it so well. Here we have other charts that really drill into the Great Circle charts relative to the Tahitian shadow. But so there, at this position, swell was coming up before it hit the shadow, unshadowed relative to Northern California and Southern California for that matter too. And then as the system got into Sunday morning, it starts moving into the shadow. Here's Southern California. You follow, what is that? It's kind of hard to see, about 213. And there's the heart of the shadow there. So yeah, really it starts getting shadowed there by this morning. And then, so let's put it into motion, and it pretty much fades out into Monday. And I'm just looking at Southern California here, but it starts moving out of the shadow here about, what is that, 203, 205 degrees. Okay, and Costa Rica, let's take a quick look there. So notice this. This is actually kind of interesting. We'll put this thing back into motion. The whole system, here's Tahiti here, the shadow. The Great Circle paths up into Costa Rica are completely, you know, nowhere near the shadow. So this is, and the system also, notice this, it was basically following right along the Great Circle paths to Costa Rica, and for that matter anywhere in Central America. So this is a good one for, and notice, look at that, even as it fades it starts tilting up. So this is what you want. Any system that's pushing right up the Great Circle paths is one, you know, you want to be at that location. So Costa Rica is a good target for this swell. Anyway, we'll put it into motion some more, see what's coming. And then things just don't really organize. This little system we're out into Thursday that was supposed to be strong, very tiny, very small, doesn't do a whole lot, and just kind of dissipates, and the whole thing kind of falls apart, and that's the end of it. Then we try to get this activity 162 hours out, but it's not strong, doesn't organize. So the jet looks good, but nothing really happens there. So let's go back. We're going to go back almost a week now. There's currently swell. It's already, for the most part, past Central America, that area, but it's starting to hit up into Southern and Northern California right now. This is sort of the tail end of that system. It was sort of a fragmented 32-foot sea thing going on last Saturday. But here's the deal again. Great Circle paths, Tahiti, right in this region, everything pretty much shadowed relative to that. We'll sort of put this back. There was a little fragment right in here relative to Northern California on the early end of this. It's probably this is a 28-foot seas, 30-foot seas, 17-second period swell. So that whatever when this energy would arrive roughly on Monday morning. So whatever's going to be unshadowed relative to California is going to hit on Monday morning. Don't expect much in terms of size though, because that fetch is really pretty small. So that played out. We had that system. And then there was another system. This one was a little bit better. Notice this 38-foot seas. This was on Wednesday time frame, and let's do the same thing here. Now this is again all shadowed relative to Southern California and Northern California. Let's take a look at Hawaii. Hawaii, the issue is all the energy is pushing pretty much sideways to the Great Circle paths, but this is not unusual. Still, sideband swell will get up there and is expected. And then it sort of lifts up. Actually, let me put this back. There you go. And take a look here. It's still in the core of the shadow right there. You got to get about this line here, was at 204, roughly 205. And so this whole system was, for the most part, shadowed. Still, good for another pulse of swell. That's expected into California next weekend sometime frame. So that's not bad. And actually, let's do the other thing. Let's take a look at Costa Rica just for fun. Again, look at that. Right up the paths. You wonder why Costa Rica is a swell magnet? Because it doesn't have to contend with the islands, and anything that's going, you know, sort of a zonal flow flat west-east is pushing right up there. And actually, let's go take just a quick look. Peru, same sort of deal. right up the paths or close enough to the paths that you're in good shape, okay? And Tahiti, of course. Anyway, so plan your trip, decide where you want to go. That's sort of that. Anyway, we'll roll this out to the present time. Those were the two systems. So the one swell, and then, oops, here we go. We'll put this out. And here's the system that we're looking at now. So swell hitting right now relative to California. Another one a week out. And then yet another. There's the one. There's the one a week out that was on Wednesday that we saw, and then yet another behind that. That's probably a few days behind. So, 3 different pulses of swell, looking pretty good at least for the summer. Take what you can get. All right, let's go look at long term, see what's going on. Do a little dive here into the MJO, Madden Julian Oscillation, El Nino, La Nina, see what's going on. The trend, Daily Southern Oscillation Index, difference in pressure between Darwin, Australia, Tahiti. Negative numbers represent the active phase of the MJO, which supports storm development in the northern hemisphere in the winter. Not such a good correlation in the summer. Positive numbers suggest the inactive phase and sort of a dampening of swell production, at least during winter months. And then prolonged stretches of negative numbers suggest El Nino. As of right now, the numbers are we had a good little bump here of negative numbers in early part of May. There was low pressure going almost directly over Tahiti. That's what sort of forced that. Now we're back into kind of a positive trend. Kind of a mixed set of numbers. The 30-day average here, positive, slightly positive. The 90-day running average, slightly negative. In all, just looking at the Southern Oscillation Index, it suggests kind of a neutral pattern atmospherically, and that's probably fairly close to the truth. Here's another view of the 30-day SOI average. Back in July 2012, we thought we were going into El Nino. In the summer, things, the SOI was sort of bottoming out, looking pretty good, but then as soon as we headed to the fall, it went back up, and whatever there was that was El Nino-like disappeared. Then we went into July last year. It was basically La Nina. Then we had this giant dip January, February, March, followed by a giant spike, and now we're kind of just hovering around neutral. So who knows what's really coming atmospherically, though there are some things in the ocean that are well worth looking at. Sort of go through the same drill as we do every week, looking at the same charts over and over and over at a regular basis. You really get a sense of trends and what's going on, and that's key to any one person's routine and what you should be looking at. Look at the same stuff, look at day after day, and try to get a good broad-based view of a bunch of different aspects of weather, so you can spy trends and make your own forecasts. So right now, kind of a neutral. There's surface level wind anomalies, differences from normal for this time of year. Pretty much a neutral pattern, normal in the West Pacific. Also normal in the East Pacific, no real westerly anomalies or easterly anomalies in play. And we also look a week out, same deal, no easterly anomalies, no westerly anomalies, dead neutral. And in the East Pacific, same deal. There's actually some interesting facts in this. There's no signs of westerly anomalies or easterly anomalies, no suggestion really of the MJO in play. That is typically what happens as El Nino starts to develop. The MJO kind of falls apart. So let's keep looking here. Here's another view of what we just saw. This is a 120 east. Let's say that's the far West Pacific, 120 west. Actually, Galapagos sitting around 80, 90 west. And then we have time down this side. The oranges and the reds are westerly anomalies. The blues are easterly anomalies. So we went through a roll January, February, March into April, all westerly anomalies. Westerly wind bursts is the tail end of the last westerly wind burst in April. We got into May, instantly kind of went into this inactive thing, weak easterly anomalies, and now things are basically turning to neutral, dead neutral. And let's take a look at the forecast and see what's going on. The statistic model says dead neutral. 15 days out, maybe some weak shades of the active phase of the MJO, but not a whole lot. The dynamic model sort of suggests the opposite. maybe some hints of the inactive phase, but overall it looks like a dead neutral pattern for the next 15 days. So this sort of bears out what we're seeing in the Southern Oscillation Index and what we're seeing in some other data, just no MJO in play. And the 40-day upper level model, the greens are the active phase, and this is enhanced precipitation. This is at jet stream level 2000 millibar. The oranges and yellows are the inactive phase, suppressed odds for precipitation. And what you get is just kind of this mixed bag. There's no, yeah, there's kind of a wave there, there's kind of a wave there, there's kind of a wave there, but the trend is very weak. No strong signature, no real winds of interest or precipitation of interest in play. But if you look at surface temperature anomalies, clearly something is going on. The oranges and yellows are water temperature anomalies greater than normal. The blues are less than normal. Clearly there's this warm signature right over the equator, anywhere from a half to a degree above normal. And notice things are definitely starting to heat up. This is as of the 15th, really in this little triangle region here. That's kind of where it all gets started if you're getting into an El Nino. And this is exactly what you want to see if an El Nino were developing, is warm waters. And this is 2.5, 2.7, 2.8 degrees above normal right in this region in pockets. So just in comparison, the 97 El Nino on May 20th, right in this region, looked very similar, but temperatures were 3 to 3.5 degrees above normal. So we're about a half to 3/4 of a degree off that and running about 10 days behind. So we're really interested. This data comes up about every 4 to 5 days. We're really interested to see what pops up on the 19th or the 20th and see if this hits the 3-degree mark. If it does, then I'd say we're approaching something that might be similar to the 97 El Nino, which was one of the strongest El Ninos on record. I don't really think that that's what's going to happen with this one, but still, just use that as a gauge. Right now, this is developed very similar to the 97 El Nino, only running about 10 days behind. The key definitor will be the update on the 20th. See if we hit over the 3-degree mark and if it holds. And what you really want to see is start seeing something turning red here. I mean, you almost see little bits and pockets, but it's all this sort of burnt orange shade still. Anyway, lots of warm water again coming off Japan towards the U.S. West Coast. The whole area is just full of warm water. And then you get a sympathetic, notice this, a sympathetic warm flow in Africa, very much like the El Nino signature sort of flow that's developing here around Ecuador, Galapagos Islands, and the equatorial Pacific. So kind of interesting. And here's yet another view. This one calls out some hot spots. 2.56. It's actually down because this region, and this is a daily updated chart. This region was up 2.7, 2.8, 2.84 I think was the highest one we saw a couple days ago. So it kind of fluctuates and deviates around, so it'll be interesting to see how this plays out. But you can see a degree above, degree and a half, 2.5, 1.9. I mean, there's a good base of warm water at the surface here, so that is encouraging. And yet one more view. You can see here basically 1 degree above normal over the width of the entire core of the equatorial Pacific, half a degree above normal, extending 5 north to 5 south over the entire width. Anomalous wind, these are actual winds here. You got east winds here, but the anomalies, notice this is actually showing light west anomalies, and the west anomalies are actually what form Kelvin waves. They take warm water from the West Pacific, push it downward into the ocean at depth, and then it works the whole way across the equatorial Pacific, and then pops up as a Kelvin wave and warms the warm waters off the Galapagos. And that's exactly what's going on right now. Here's a different view of that same thing, only this is sea height deviation. Deviations from normal, 5 centimeters above normal, a little pocket of 10 there, another little pocket of 10, and a 15 there. Warm water at depth pushes surface water higher. The Jason-2 satellite makes passes over, and over the period of about a week can basically cover every square inch of the planet, and so you can sort of get a signature here from it like that. So this basically supports what we're seeing in other data. And now here's the at-depth view, meters, 100 meters down, 200 meters, and so in the far West Pacific, 140 east, 160s, here's the date line, and then you get over to here, the Galapagos are just off the chart here, and this is what you call a Kelvin wave, warm water. Basically, it went down, it got blown down by strong westerly anomalies in January, February, March, into April. 4 months of non-stop westerly anomalies pushed piles of warm water to the east. That Kelvin wave is erupting now off the Galapagos in Ecuador, and that's what's making all the warm water that we're seeing in that region, in that triangle region. It's warm water pushing to the surface. And yet one more pulse of the Kelvin wave. This is from a westerly wind burst in April, and it's working its way as a reinforcement to come back in. So the question, though, becomes, is more warm water going to start working its way east? We need some westerly anomalies. Doesn't have to be strong, just some weak westerly anomalies to keep the sort of the spigot open and warm water traveling in this path. There's certainly no sign of any, if it was like a La Nina, you'd see a pocket of cold water right here. It'd be a hard barrier, a brick wall. None of that's going on. So the spigot is open. There's, plenty of flow there, but if you want a superheated sort of situation, we would want to start seeing westerly wind bursts. But the other side of it is the early summer months aren't real strong for that. The machine would really start probably firing up again in later July, August if we were getting into an El Nino situation. And here's another version, sort of a different modeled version. It's showing the same thing. It's showing the spigots open here on the date line, water diving, downwelling, and then warm water working its way to the east. It's showing here in the 5-degree range, whereas this was showing more 4 degrees. So I'm not sure if I completely believe this. There's not, oh, and here's the other thing. See, there's these X's are sensors. There's no sensors in this region here between what is that, 155 and 110 west. So on this image, that'd be about from here to about here. So it's a model of what's going on, and it's quite unknown exactly how warm the water is. A good chunk of the TO array is down. It needs maintenance. It needs funding. This is all a result of budget cuts and whatnot. So the science is kind of lacking due to lack of funding. So there's sort of unknown exactly how warm the water is here, but still gives you kind of a sense of what could be happening. And finally, a prediction, the latest update from the CFS version 2 model, Nino 3.4 region, the main region for monitoring El Nino, La Nina. The model here suggests once we get into October, November, we're talking water temperatures 1.5 degrees above normal. That's a pretty good sized region. That's pretty warm temperatures. If you want to be historical, like the 82, 83 El Nino, or the 97, 98, they were up in the 2 and 2.2 degree range. So this is shaping up, at least per the model, as kind of a moderate El Nino, similar to the 2009, 2010 El Nino, which is fine. That's good for big surf in the winter. Not so much all the death and destruction of the bigger El Ninos, and maybe it gives you some hope that the local winds won't get too out of control in California, and you could actually have giant swell and some reasonable winds instead of a blown out south wind rainy mess. So at this point in time, it looks like, again, Kelvin wave, pushing towards Ecuador, warm water upwelling. We're watching the next 5 to 10 days to see how warm it gets, to get a sense of maybe some historical perspective on whether this El Nino will be a big one or just a moderate one. Assuming it forms at all, there's still a million things that could come to derail it, but at this point, things are looking pretty good. And then, of course, in the short term, 3 southern hemi swells on the way to the U.S. West Coast down into Central America and Peru and Chile. So waves for the short term, hope for the long term. This is way better than we've been for a couple of years, so this is good news. And there's nothing we like more than the chance to know that there's surf coming versus the other way around. So things are looking pretty good. This has been a good update, and it's fun to do. Anyway, that's it. We'll do this again next week. Same time, same channel. And if you get a chance, go check out our friends at vunabaca.com. I think they have some postings up on the construction of the site there, and it's really a very interesting project, and it would be a great place to have a vacation home or a retirement home or whatever you can afford. We can always dream, that's for sure. Anyway, thanks a lot, and we'll do this again next week. Thank you.